Okay, physics fans, here comes lesson number 2. And this one it's just some details I got to make sure you know and you understand throughout to get you throughout the course. There's not stuff that's specifically related to our curriculum. Really, it's just stuff you need to know. And the first one is scientific notation. I'm guessing at some point in your life you've seen this before, at some point in your education. But in case you haven't, we're going to see it here. So, what and why? Scientific notation is a method to write very small or large numbers easily, and we do sometimes in this class. Specifically, we do questions related to gravity, where you need to maybe know the mass of the Earth or some other planet, right? So there's the mass of the Earth, and you want to write that down. You're sitting there, you're counting out all the zeros. Well, instead we can use scientific notation, and in scientific notation, the mass of the Earth is 5.98 times 10 to the 24. So I know that's true, and so when I use my calculator and I punch in 5.98 times 10 to the 24, and I suggest, well, when you get to doing questions with scientific notation, I'll take a look over your shoulder and we'll just make sure you're punching them in right, because different calculators do them differently. And when we do calculations, I'll show you on a calculator on the computer, and hopefully you get the idea. So that's scientific. So the question is, how do I get from here to here? How do I know that it's a 24 and not a 26 and not a 23 or not an 18 or something? So here's how you do it. I'm not going to do this example just because there's too many numbers. We're going to do smaller numbers. So 34,000. Say I want to write that in scientific notation, which you might say, why would you bother? But we bother because we want to learn how to do it. So if we want to do that, the first thing you do is you write the first, 3 is the first, non-zero number on the left of the decimal place and the remaining on the right of the decimal place. So in this case, 3.4. And then I won't bother writing all those zeros here. Okay? So 3.4. Then you add the times 10. So that's part of scientific notation. And then the exponent on the 10 is going to be the total number of digits, assuming there's no decimal places, and it's everything on this side of the decimal place. So say it was 34,000.00. You wouldn't count the 0.00 or the 0.21 or anything that would be on the other side of the decimal. Only you're looking at whole numbers here, okay? So you take the total number of digits and you subtract 1. So in this case, it'll be 4. Okay? So that's writing a large number in scientific notation. So let's just write this one out, okay? I have the answer underneath my box there, but 198,000. So it's got to be, the first step was to write, okay, it'll be 1.98 will be the beginning. Okay, then you write the times 10, and then the question is what's the really only thing is what's the exponent going to be. So I count up 3 6-digits there, so the exponent's got to be 5. Okay? And that's writing big numbers in scientific notation. Small numbers, another thing, and I don't know if we're going to do, there might be a couple things we do with mass of electron when we get to electricity, but either way, you might see it. Or sometimes if I give you questions out of a textbook at some point, the answers will be in scientific notation. Like, you should be able to understand it. So say, there's an example, though. I'm not writing that out. I'd much rather write this, and that's why I would do it for small numbers. So I'm going to show you the rule. So say I'm going to take this one, which is, again, a nice smaller number. You do the same thing to start. You write 4.5. Okay? And if there was zeros, say over here, like say it was 000450, you might be tempted to write 4.50, but you don't have to. But if it was 453, you'd go 4.53. And then times 10 too, and this time you have a negative exponent because a negative exponent will make it a smaller number. And then what you do is you count up the zeros here. You don't count any zeros that might show up on the other side. You only count zeros on the left of the first non-zero digit. So I count 4 zeros, so it's going to be times 10 to the minus 4. Okay? So again, just to the answer, say I had that there, it would be the exact same answer. Okay, so the zeros that you count are only these zeros, sort of on the left of the digit. Okay, so let's just do this one, and there I made the example with a 0 on the side there. So it's going to start with 6.2, and I put the 0 there. That 0 is not important. It doesn't change the value of the number, so you could have it there or not have it there, but it refers to this 0 here. So it doesn't have to be there, but it can be. Times 10, and here's the part. It's a negative exponent, and the exponent's going to be 1, 2, 3, 4, 5, 6. Okay, so you just count up all these zeros here. Okay, that's scientific notation. Second thing I want to go through is sometimes we use negatives in physics. I'm not talking about negative exponents now, I'm talking about something like negative numbers. And almost exclusively, negative numbers in physics refer to a negative direction. And what that means is we call something positive, say north, that means south would be negative. Okay, and that just helps us with calculations when you'll see later on. Okay. So say Ferd walks this trip here, and we want to find displacement. Well, we did a question like this in the last note, right? You kind of can draw it out and figure it out. But another way you could do this question would be to say, I'm going to call north positive. You could call south positive. You would get the same answer. But then when I find my total displacement, then I can just say it's going to be 20, because that's a positive number. But the 60 is negative, because it's south. And the 150 is positive, which is north. So the displacement ends up being 110 meters, which it's a positive number, right? 20 minus 60 plus 150 is positive. So I could just leave my answer as that. Once I've called north positive, I can just say, okay, my displacement's 110 meters, positive. Or you could then say, it's north, 110 meters. So either of these are a correct answer, but just another way to do it is just, sticking in negative, calling the 60, the south negative, and adding up your displacement that way. And sometimes when we do harder, like we're going to talk about negative accelerations later on, stuff like that. But for now, that's just the idea of it. So when you see a negative, it should refer to direction. And when you do a question, sometimes you have to call a negative. And we'll talk about that too with gravity, but we'll see. Okay, third thing I wanted to go through is unit conversions. So you may have seen this in one of your math classes, depending on what math you've taken. There's an easy way to do unit conversions, which I'm going to show you in a sec, okay? But I'm going to show you the idea behind it, okay? And then I'll give you some tips, and I'll give you the sort of the way to do unit conversions anymore. Now that we live in a technological world, you don't really have to think anymore. But if I wanted to find 1,200 grams in kilograms, you might just know in your head divide by 1,000, right? And that is correct. But the reason you're dividing it by 1,000 is you're really saying, I want to get rid of that gram. So it's like you want to divide by 1,000 grams to cancel the grams out. But let me show you something here, just one sec. So what was it, 1,200 grams? Here's how you really do it. 1,200 grams in kilograms. Google right now has a unit converter built into it. So if you're in Google Chrome, 1.2 kilograms. Say I want to do a different unit conversion. That's not mass. Let's say distance. Let's say 1,000 meters in miles. There you go. Okay, so your unit conversions, and you can always do this if you need to. Generally, you can just use the unit converter. But the idea behind it, the math behind it, and I know that some of the math courses, a lot of the math courses teach you this process, right? And I teach it a bit more thoroughly in some of my other classes too, but the idea is you're just multiplying it, kind of like multiplying it by 1. But anyway, here's the one we do all the time. The one that we're going to see all the time is meters to second to kilometers per hour, or vice versa. So say I want to take 45 meters per second, and I want to know what that is in kilometers per hour. Well, the process that I showed you is you say, okay, well, there's 3,600 seconds in an hour, and there's 1,000 meters in a kilometer, and I work all that out, and then I can cancel my seconds and cancel my meters, and I end up with 162. And you're saying, I can't do that. And you can, for one thing. Easily you can, but I'm going to show you. The trick is, if you're going from meters per second to kilometers per hour, you multiply the number by 3.6. Okay? And the reason is, if you look at this, it's like I've got 3,600 on the top, 1,000 on the bottom, which works out to just multiplying by 3.6. The other way to do it, like I showed you, 45 meters per second in kilometers per hour. Just write it down. 45 meters per second, right there. You don't have to think very hard. 162. Okay? So there's different ways you can do it. If you want to use the Google Converter, I'm totally fine with that. If you want to remember that rule, most of the conversions we do are 1,000, right? From kilometers to meters, or centimeters to meters would be 100. A lot of them you could probably do in your head, but if you're doing this one, this is the most common one, going meters per second to kilometers per hour, you multiply by 3.6, and if you're going from kilometers per hour to meters per second, you divide by 3.6. Okay, so a couple unit conversion practice there. We can try those out. Divide by 3.6. So when you're going from kilometers to meters per second, divide by 3.6. So 100 kilometers per hour is 27.8. And this one I'm going to multiply because I'm going from meters per second to kilometers per hour, multiply by 3.6. So again, if you wanted to, you could just stick that into the Google Converter and it would do it for you, right? So 100 kilometers per hour to meters per second. .8. Okay, so whatever way works for you, I'm fine with. Okay, it's just that it is something that will come up in the class. You'll be given questions that aren't in the right units, and you've got to get them in the right units. And what I mean by that is, generally we do calculations with meters per second, meters, seconds, kilograms. So if you're given something that's not meters, seconds, or kilograms, you got to get them there. Okay. Yep, that's it for that lesson. So you'll be able to practice it a few times on the practice as well.